Howdy guys, Jimmy Song here. In this video, I'm going to talk about Dandelion because this has been getting some hype and a lot of people have heard about it. They don't really know what it is. So in this video, I'm going to explain to you what it is. So the thing motivating Dandelion is the fact that when you transmit a transaction, people know your IP address, right? If you're a light wallet or if you are a full node, whatever you are, you have to transmit the transaction to the network. And based on where you are, and if you're connected via IPv4, IPv6, which is most people, then you're going to reveal sort of the location or who, that the fact that you sent that transaction. Now, that can be mitigated by connecting through Tor and things like that. And I know Wasabi Wallet, for example, automatically transmits transactions through Tor so that there's no de-anonymization effect. But oftentimes that it leads to its own problems, because if you have an exit, all transactions coming out of like a Tor node might be sort of seen as suspicious or something like that. So to sort of make every transaction quote unquote equivalent, they came up with with a protocol in order to make it so that you can't tell where that transaction came from, and that protocol is Dandelion. So what is Dandelion? Why is it called Dandelion? Well, first of all, if you think about how a dandelion looks, it's got a stem and then like a bunch of fluff, right? Like and you can blow it and all the seeds go out and stuff like that. That's what a dandelion looks like. And the name was chosen because there's something called the stem phase. And it's one long unbroken string, like a string of connections, and then you have something called the fluff phase, where the transaction is transmitted to everybody on the network. So what happens during the stem phase is basically, if you are transmitting a transaction and you have some nodes that you're connected to that support Dandelion. That's BIP 156, by the way, if you want to go and read it. Then you would connect to that node, and you would transmit your transaction to that node. Now, that node will take that transaction and not just sort of like send it out to everybody. Instead, there's a probabilistic thing that it has to do. So usually the probability is around 10%, but it determines through some random number generation or something like that whether or not it's going to transmit the transaction to everybody else. So at that point, it'll go, okay, well, it's 90% of the time it'll just keep going on the stem phase, but 10% of the time it'll go into the fluff phase. So if it goes into the fluff phase, that means everyone it's connected to will immediately know about that transaction, but it won't be you, right? Like it'll be somebody else transmitting it, so it'll look like that person, that other node has transmitted that transaction. 90% of the time, it'll continue on the stem phase. So it'll connect to another Dandelion node, or I think you designate at the beginning exactly what endpoint you desire, or something like that. But it'll keep going on that stem phase, and every node each time has this probabilistic determination to make whether or not it's going to be in the fluff or the stem phase, and that's why it keeps going. And then eventually it'll reach the stem phase. It'll end the stem phase and it'll reach the fluff phase, and it'll be a node that's at least from a network graph standpoint very far away from you, and it'll look like that node transmitted that transaction, and it it'll make it so that you preserve some privacy, and that's a very good thing. That's exactly what you want out of something like a protocol like this. Now, what's the problem here? Why can't we have this right now? Well, as with anything, there are certain trade-offs that you have to think about. So any transactions routed via the Dandelion protocol don't go into a node's mempool, and this is the answer that Suhas gave, and he's a core developer, in a Stack Exchange answer about the trade-offs of Dandelion. And the main one being that, like, because Dandelion transactions don't go into the mempool, you don't know if they're valid or not. If they went into the mempool, if you had some complicated logic that said, okay, would this fit into the mempool, then that would be fine. But that itself is that's a very hairy thing to write into the code, right? Like, would it be okay to be in the mempool right now? So there's no way to sort of validate it very easily without like a very large rewrite of a large amount of systems. But if you could determine that would solve it. But I mean, there are sort of mempool considerations already. Like the mempool, for example, does like signature validation last as a way to prevent denial of service attacks against it. And there are lots of sort of ways in which you can attack a node. But a lot of those are mitigated by sort of the mempool logic, and any Dandelion transaction would have to go through those filters. So it makes it, the security trade-offs are kind of significant. So that means that if at least a naive implementation of Dandelion would be, okay, you send a Dandelion transaction to a peer, they don't know if it's valid or not, and then only if they hit the fluff phase do they go, okay, well, now I'm going to transmit it. At that point, it goes into their mempool, and at that point, it might be like, oh, well, this is an invalid transaction. And that would be a way to denial of service the entire network, because you can just flood it with these Dandelion transactions to every node, and they would transmit it, and eventually, like, and you wouldn't really even know where it came from, right? Like, because of the Dandelion stemming, and you would at that point figure out, oh no, this is an invalid transaction. You would have spent CPU cycles trying to figure out if this transaction was valid or not after it's been propagated quite a bit. So I mean, these are considerations and things that people are trying to solve right now, but that's what Dandelion is. But I mean, bottom line, it gives you privacy when you transmit a transaction. When you send Bitcoins to somebody, instead of being able to figure out based on your IP or whatever connection you have, there's more privacy because it goes through a bunch of hops before it is transmitted to the network. Anyway, that's what Dandelion is. Hope that helps you. This song is done.